Here is the next example. In this example, he's asking about find I by using nodal analysis in the given circuit. Okay, step 1, find all the nodes and choose one of them as a reference nodes, and choose one of them as a reference node. All other nodes, label them as v1, v2, v3, something like that. So here I chose this as v1 and chose this as v2 and the bottom one as v reference. Okay, as I mentioned in the previous videos, this node, this node, this node, this, everything same because there is no element exist here. Okay, so all these nodes are together as a single node. We will consider that as a single node. Now step 2, see if you have any voltage source between the reference node and unknown nodes like v1 and v2. Do I have a voltage source between v1 and v reference? No, this is a current source. So you cannot find v1 by using VAB equal to VA minus VB formula. Same thing with v2. Here, if you want to simplify it, I can clearly see 4 parallel with 2 because they both of them connected between v2 and v reference. Since our goal is finding I, which is not going to disturb us, so you can combine 4 parallel with 2. So if I combine 4 parallel with 2, which is 4 times 2 divided by 4 plus 2, which is 8 by 6, which is 1.33 ohms. So I can replace this 4 ohms, 2 ohms with 1.33 ohms. At this point, I'm going to leave them 4 ohms and 2 ohms. Now at V1, apply KCL. Okay, I'm applying KCL at V1. So I'm going to choose, this is my I1, I2, I3 and I4. All currents are going out. I1 equal to minus 2 ampere, I2 equal to V1 minus 0 over 1, I3 equal to V1 minus V2 over 2, I4 is nothing but 2I. Now I want to have every element in this equation in terms of V1 and V2, not I. So I'm going to replace this I. So if you look at here, I2 is same as I. So can I say, I already wrote I2 equal to V1 minus 0 over 1. So I can replace I with V1 over 1. So that's what I did here. And I multiplied with 2 to simplify this equation. I simplified it and ended up with 7V1 minus V2 equal to 4. Okay, that's my equation 1. Now equation 2, at V2 apply KCL. So what I did, I chose this as my IA, IB, IC, ID. All currents are going out. Okay, IA plus IB plus IC plus ID equal to 0. IA is nothing but minus 2I, but I already know I equal to V1, so I replaced I with V1, plus IB is nothing but V2 over 2, IC is nothing but V2 over 4, ID is nothing but V2 minus V1 over 2. Now multiplying with 4, minus 8 V1 plus 2 V2, I mean 4 times V2 divided by 2, which is 2V2, 4 times V2 divided by 4 plus V2, 4 times V2 minus V1 divided by 2, which is 2V1 minus 2V2 minus 2V1 equal to 0. So minus 8 minus 2, which is minus 10V1 plus 5V2 equal to 0. This is my second equation. Now I'm simplifying these two equations. So 7V1 minus V2 equal to 0. That's my first equation. Minus 10V1 plus V2, 5V2 equal to 0. That's my second equation. So to eliminate V2 in both the equations, I'm multiplying first equation with 5, which is 35V1 minus 5V2 equal to 20, minus 10V1 plus 5V2 equal to 0. So 25V1 equal to 20, V1 equal to 0.8. Now I substituted V1 value in the first equation. So 7 times 0.8 minus V2 equal to 4. I end up with V2 equal to 1.6 volt. But my goal is finding I. I is nothing but V1 over 1, which is V1 is 0.8 divided by 1, which is 0.8 ampere. Here is the next example. here he's asking us find the ix by using nodal analysis. We know that when do we use the nodal analysis? Nodal or mesh, as long as there are two or more energy sources, we'll use either nodal analysis or mesh analysis. Now step 1, we need to find all the essential nodes or a node and label them. So here I can choose this as one node, second node, third node, fourth node, fifth node, sixth node. Okay, so here I have 6 nodes. Solving this by using this many nodes will end up with you're going to have one reference node. That reference node voltage is 0. Okay, so still you need to find all other 5 node voltages. So to simplify this, instead of solving 5 node voltages, can I combine any of these elements before solving it? So if you look at here, so the current flowing through this 2 ohms and this 2 ohms. So whatever current coming here, say I current is going to enter there, I current is going to enter there, I current is going through these 2 ohms. So basically I can see the 2 ohms and 20 volts and then 2 ohms, all these 3 in series. Since these 3 are in series, can I combine them and move that 2 ohms up here? Okay, then make this 20 volt and 4 ohms. I can do this. Okay, that's for sure, since these 2 ohms and 2 ohms, they are in they're carrying the same amount of current or same current. We can say those 2 are in series. So I combine those 2 resistors, make it as 1 resistor. Okay, that's legal. We can do that. Same way I can do the other side. So what I'm going to do, I'm going to simplify the circuit. Here I will end up with 2 plus 2 ohms, 4 ohms, same thing, 1 plus 3 ohm. Now my circuit is going to be so simple. Now I'm going to take this as a reference node. This is V reference, that value equal to 0. This is 40 volt, 20 volt. Okay, now our goal is finding Ix. Okay, now step 1, find all the nodes, label them V1, V2, V3 and V reference. Okay, previously I had 6, now I end up with only 4, and at the same time it's easy for me to find V1 and V3. If you remember, step 2, I have a voltage source between my unknown node as well as V reference. Okay, that's basically ground. The ground symbol is, this is the ground symbol. I'm not doing it right. Okay, that's the ground symbol. So this is V reference equal to 0. So I can write this as V1 minus V reference equal to 20 volt. So V1 minus 0 equal to 20 volt. So I can take V1 equal to 20 volt. Same as V3. V3 is also 40 volt. V3 minus 0 equal to 40. So now all I need to do is at V2 apply KCL. Okay, as usual I'm choosing every current is going out of the node, I1, I2, I3. So I1 plus I2 plus I3 equal to 0. What is I1? I1 is V2 minus V1 over 4. I2 is V2 minus 0 over 4. V3 V2 minus 40 over 4 equal to 0. Okay, so here I already know V1 equal to 20. I'm going to substitute V1 equal to 20 to minimize calculations. So I can clearly see, if I multiply this with 4, V2 minus 20 plus V2 plus V2 minus 40 equal to 0. So here 3V2 equal to 60 volt, V2 equal to 60 over 30, 60 over 3, that is 20 volt. So that means V2 equal to 20 volts. So the voltage at this point, I found the voltage at this point as 20 volt. That indicates that basically there is no current passing through this. I mean, we can verify that. So what is I1? I1 must be 20 minus 20 over 4, that is 0 ampere. What is I2? 20 over 4, which is 5 ampere. What is I3? I3 equal to 20 minus 40 over 4, which is minus 20 over 4 minus 5 ampere. So basically that indicates that I3 is flowing in the opposite direction. So basically this is supplying current, this is not supplying any current. It's not because of it doesn't have any energy, it's because of the elements we arranged in the circuit. It's not going to make any difference even though elements are like this. It's still the current passing through that circuit, or current supplied by the 40 volt source is 5 ampere. I mean, it is supplying. Current supplied with 20 volts is 0. Okay, and Ix is nothing but 5 amperes, because I already know V2. I just found V2. Ix equal to V2 over 4, 20 over 4, that is 5 amperes. I'll stop it here. Thank you.